Hey friends, welcome. Memory management is one of the most important components of an operating system. In this lesson, we will concentrate on one of the memory management schemes, namely contiguous memory allocation. Note that when we say memory, it means the main memory. Main memory has two partitions, one where the operating system resides permanently with the interrupt vector, which is usually in the low memory, and the other, the high memory, which is allocated to the user programs. It is essential to know that all user programs have to be mapped from the logical address space to the physical address space. Contiguous memory allocation can be done using single partition or multiple partitions. Single partition allocation requires two registers. Number one, the relocation register, and number two, the limit register. The relocation register contains the value of the smallest physical address. This register is used to protect user processes from one another and from changing operating system code and data. The limit register contains a range of logical addresses. Also note that each logical address must be less than the limit register. Now this diagram clearly shows the mapping of logical address to physical address using the relocation register and limit registers, which we spoke about earlier. Every logical address generated by the CPU is compared to the limit register. We already know that logical address must be less than the limit register. If this is true, then the value of the relocation register is added to the logical address, thus generating the corresponding physical address. Likewise, the entire program, that is the logical address space, is loaded into main memory. If any logical address happens to be greater than the limit register, then there is an addressing error which is trapped by the operating system. Now moving on to the multiple partition allocation. As in single partition, the operating system resides permanently in low memory. Therefore, the diagram shown below, the remaining memory space is split into multiple partitions called holes. The hole is a block of available memory, and these holes are scattered throughout the memory. Each process allocated memory from the hole that is enough to accommodate it, and it is the responsibility of the operating system to maintain the allocated and free partitions. The figure shows the block diagram of memory. We see that the operating system resides permanently in the low memory. The user processes occupy the holes of the memory as and when they arrive. Once the execution of a process is over, it is deallocated memory space and the hole is returned. Now coming to the problem of satisfying a request of a process of size n from a list of free holes, which is referred to as the dynamic storage allocation problem. There are three different solutions to the problem: the first fit, the best fit, and the worst fit. First fit allocates the first hole that is big enough. Best fit allocates the smallest hole that is big enough to accommodate the process. The leftover hole is the smallest, and hence this method is called best fit. Worst fit allocates the largest hole. This method produces the largest leftover hole. Best fit and worst fit methods require the ordering of the list of holes, or the entire list has to be searched. First fit and best fit are better than worst fit in terms of speed and storage utilization. And finally, about the disadvantage of contiguous memory management. Fragmentation is a limitation in contiguous memory management. Leftover hole is called a fragment which cannot be reused. There are two kinds of fragmentation: external fragmentation and internal fragmentation. When the total memory space exists to satisfy a request but it is not contiguous, then it cannot be allocated to the process. This is called external fragmentation. When the allocated memory is slightly larger than the requested memory, this size difference in memory cannot be used because it is internal fragmentation. One solution to the problem of external fragmentation is compaction. Compaction means shuffling the memory contents and placing all free memory together in one large block. Compaction can be done only at runtime, that is, if relocation register is dynamic. Another solution for external fragmentation is making the memory non-contiguous, that is, paging and the segmentation schemes. Hope you found the video useful. Thank you.